CVT is a very common and popular transmission system worldwide due to its practicality, and as a result, we often see it used in scooters. Without further ado, let's take a closer look at how it works and all of its parts for a better understanding. We'll start by looking at the primary pulley, which typically consists of two conical plates: the primary sliding pulley and the primary fixed pulley. Moving to the back, we'll also find two tapered plates: the secondary fixed sheave and the secondary sliding sheave. More details on the secondary sheave. We'll see a compression spring that functions to keep the sliding plates close together. This condition forces the belt to stay on the largest diameter of this pulley. On the other hand, at the drive pulley or primary sheave, the axial stiffness of the belt will push the primary sheave to its farthest position. This causes the primary sheave to have a minimum diameter. This is a high torque, low-end speed condition. Now, in order to achieve higher speed on the wheel side, the diameter of the primary sheave must be made smaller, and the diameter of the driven secondary sheave must be increased. Okay, let's understand how this is accomplished in a real Scooter CVT. First, let's take a closer look at the primary sheave. On the primary pulley, we'll see a set of weight rollers as shown here. When the engine is at low RPM, the pressure of the spring on the secondary pulley will keep the rollers in the center of the pulley. As the engine speeds up, centrifugal force causes the rollers to move outward along the curved surface. These rollers will work to push the primary pulley as the cam plate holds its position, forcing the pulley to move toward the fixed pulley. To make it easier to understand, let's look at the diameter changes in slow motion with sample sheave conditions that result in low torque and high speed. As we can see in the demonstration, as we mentioned earlier, the centrifugal force causes the primary pulley to move, gradually overcoming the force generated by the spring on the secondary pulley. But it doesn't stop there. This transmission system also includes a centrifugal clutch assembly that functions to disengage and engage the rotation generated by the engine to the wheel. The inner part of this clutch consists of weighted arms held by tension springs. These arms are connected to the pulley or secondary sheave, while the clutch housing is connected to the output gear. When sufficient speed is reached, centrifugal force causes the arms to swing outward, and the friction linings come into contact with the clutch housing. This clutch housing functions to transfer power through the gear train to the rear wheel until it reaches the scooter wheel. And there you have it.